Okay, I will draw a 4-unit circle because when we're talking, yeah, I draw unit circle 4 because there's a different quadrant. The angle is different. You see, I draw 4-unit circle for you. From here, you can, So the radius is 1. It's called unit circle. So what I do is to put it as a vertical axis.
Isn't it from pi to 2 pi?
Yeah, that's pi to, not from 0 to
2 pi.
2 pi, yeah, that is use radians. The reason I drew this 4 because the angle can land it at any quarter, right? The angle could be very large, could be very small. If it's small, it's just in the quadrant 1. But if the angle is large, it could be any of these, any one of these. So the first scenario, the first case is that the angle is in the first quadrant. Can you see the angle here? The angle here, right?
Yeah.
Second, I just use this one. This is the first quadrant. Can you see? First quadrant. I use this first because it just makes sense. Okay, this first quadrant. Okay, and this is the second quadrant. Can you see that? This is the third quadrant. This is fourth quadrant. So anything in between. Okay, anything in between. So in this way, we can define the angle. Now I can just draw. In this way, we can define this angle. So the chemical is chemical. This is a theta. Can you see? Oh, sorry. This is angle. Can you see? And this is angle. Can you see? I use this angle close to to x-axis.
Oh, okay.
See, this angle is called reference angle. Okay, it's called. Can we put the? So this is theta r. You see, this is theta r. R for reference. What's wrong with mine? And also this is the reference angle. Okay. Now this angle is called theta. All right. This theta is between you know
it's
that this
reference?
Yeah, that's it's just because it's smaller than 90 degrees.
Oh.
So you can use this angle to define the sine cosine ratio. This is a 0 degree. This is 2 pi. Actually not 2 pi, but n2 pi. Can you see? N2 pi. So you have to get used to that. N can be any number between. So n equal to 0, 1. So not just 0. N equal to 1, 2, 3. Okay, multiple. That's every 2 pi, integer. So the reference angle here to represent this angle, can you see? That is something you need to know. So this angle, because this angle this time is larger than, this angle is larger than 90 degrees, can you see? So in this case, I have used this reference angle. Okay. And when the angle is over here, then this is another angle you can use, can you see? That's angle. So that's what I call reference angle. And this is used to represent this angle from here to here. Can you see? So this is theta. So this is a reference angle. Now the reason we use the reference angle because we can only find the right angle triangle. In this case, can you see? We can only find a triangle here. Can you see right angle triangle here? Right triangle here. This right. Can you see the right angle triangle here? Right angle triangle here.
You can use the sine, cos, and tan to solve for the first.
Well, yes. The reason I draw 4 because I noticed students get confused. Why? How can we count the theta? So you can count the theta at any position, okay? But when you actually talk about the sine, cosine, you have to use the right angle triangle here. Can you see? Okay. So this right angle triangle, if you call, normally we just call this y, this called x, can you see? So in this definition, it's called unit circle. In the unit circle. In this case, we can define sine theta. Can you see? Theta can be anywhere. Theta will define as because this is 1. Can you see? Unit circle means the radius one.
Opposite over hypotenuse.
Okay. So what is theta? Sine theta?
Opposite over hypotenuse.
Yeah, that should be the y over 1 or equal to y. Can you see that?
Okay.
How about cosine theta?
Adjacent over hypotenuse.
Adjacent over hypotenuse. That's just x. Can you see?
Mm.
That seems to make easier. So that's 12 over 10. That is 3
That's
basic.
opposite over adjacent.
That's y over, can you see? That is radius. This is a coordinate. Can you see? X, y. So that is in this way, we can just define the trigonometry function as x and y. Can you see? Oh, that's it. That's it. I just stop here. So let's talk about the sign first. The sign, okay? The sign, because it could be negative, could be positive. Okay? One is the sign of the trigonometry. Now, in the first gradient, in this case, in the first quadrant. So if the theta, is a bit, yeah, right? Yes, right. Is larger or equal to 0, but smaller than 19 degree, half pi. And what is sine? Sine says positive, negative?
Positive.
Yeah, sine theta is positive because y is positive, right? But how about cosine theta?
Negative.
No.
Positive.
Positive. You see, this is 0. Can you see?
X.
Yeah, x. Because you whether is how to determine sine of x.
Oh.
You understand?
So these are the new expressions, right?
That's right. So probably I don't want to write it. That makes things easier. If you know the ratio now, I just write this as. This is the first thing you need to understand. That's just y. Can you see? Only this expression only apply for the unit circle. Okay. If you don't use unit circle, don't use this formula, right? If that's give you the proper name. So, how about tan? About the tan theta, tan is y is positive, x positive, positive divided positive is positive. Okay, makes sense.
So it's
okay?
all positive in the first quadrant.
Okay. Now in the second case, the quadrant, in this case, how about the sine? Sine theta. Sine theta is y. Sine theta is y. Yeah, that's why I said
cos is negative.
Yeah, cosine x is negative. Can you see? So cosine is negative. How about the tangent theta?
Oh, that's y.
Y is positive.
Negative.
X tan is also negative. Can you see? So that's how to determine the sine. Okay. Once you determine sine, then you can use this angle to work out. You can use a reference angle to work out the tan theta, different angle. How about this case? How about the cosine? How about the sine theta? Sine theta positive negative is negative because y is negative. Can you see? How about cosine theta?
Tan is positive.
Cosine.
Cosine negative.
Negative, yeah.
And tan is positive.
Yeah, negative divided by negative, so that's a 10. Oh, sorry, just 10. So it's positive. Can you see? That's strange. Positive. How about the last case? How about this case? Quadrant 4.
Negative.
Sine theta is this y negative. Yeah. So first thing determine the sine and cosine theta.
Negative.
No.
Oh.
Cosine.
Oh, it's positive.
Yeah. Can you see that? Because you follow the x. You follow the x.
And then y over x.
How about 10?
Negative.
Tan theta.
Negative.
Negative? Yes, because one of these is a negative y, positive x is negative.
Yeah, but one of them is negative.
Okay, so that is how to determine the sine. Okay. Once you determine the sine, second is to determine the notch value. So what you can do, for example, if you have, how about the sine, how about the sine, in this case, I use this theta, in this theta, can you say, I call this theta is a pi minus reference angle. So this is reference angle. So that would be this theta. Can you see?
Okay.
So negative, positive. Pi minus. Or can I write? Can we just rewrite this as so? This is whole thing is theta. Can you see? This is called theta.
Well,
We go to example. For example, how about the sine 150 degree? Positive or negative? 160 degree. 你看不见了。
我看得见。
糟糕。
那我看得见。
Sine is positive, can you see？ 那就应该但等于 positive 多少呢？你就要重新写一遍，好不好？You have to sine that is 180 degree minus 30 degree. Can you see? So this 30 degree is called reference angle. Can you see? Which is less than the reference angle. The reference angle is always less than 90 degree. Okay. Or half pi.
But can it be 90 degrees, like exactly?
Well, 90 degrees is a special angle. Everybody knows the answer.
Okay.
In that case, you have to go to special angle. That's another issue, okay? The special angle, we're talking about that later, so special angle. Okay, now if we know that one, so that will equal to positive sine 30 degree, can you see? So this sine is determined by this row, can you see? In the second quadrant, because they are in the second quadrant, okay? So what is sine 30 degree? That's a special angle. Half. Do you remember that? It's half. Do you know this? Why? 你还没学这个是吧? You need, but just take this example, okay? Okay, now it's I just next time we talk about
special. I roughly learned about special angles.
Yeah, special angle. Can you say the special angle?
Circumference.
Special angle. This special angle includes 0. Can you see? 0.
380 degrees is like 2 pi r.
Yeah, that's we can use quarter pi. So we can use this one first. 45. These are special angle. The special angle should be worked out exactly without a calculator. 90 degree, and that's 180 degree, and it's 270 degree. And 360 degree.
Oh, sorry. The video I watched, he said you only have to remember 360 and 180.
Oh yes, I know. And it's just I'm not about. I'm talking other things. Okay, there are many other things. So this is reading. This is readings. This is a degree. That is just a degree. There's a degree. Is a unit.
Okay.
Degree. And radian. Just reading. Okay, that's 0. Can you convert that to this is 2 pi? Yes, that's right. I only remember how 100 equal to pi. All right. So how about 45 degree? How about 90 degree? 180. So remember this. So it's 180 degree equal to pi radians. Okay. You only need to remember this. You can convert that. 180 to 1 pi. 90 degrees is a quarter. How many pi?
Quarter is 1.
No. Half. It's return. Okay. So this is 0 degree. This is half pi. Can you see? This is pi. How about this pi? This is 3 half pi. Can you follow me?
Oh, yeah.
Okay. So let's just return to this. So about how 45 degree. 45 degree is divide 90 degree by half. Denied, but what is reading?
Divide a pi over 2 by half.
Yeah.
Then
half and half. Quarter. That's right. Now let's listen to the so 180 degree equal to pi. How about 6 degree? Is 6 degrees is 1/3?
Yeah, 1/3. Then pi over 3.
That's how to remember how to convert that. How about this one? So 6 divided by half and half. How about 30 degree? Half.
Half.
Is that half?
No, OK, I get it.
所以36与18呀，36与18就是它，
2
你乘个6，你如果乘3个6，它六个30度就乘它，这记住了吗？ Then that if you still have trouble, that's how I show you. You just remember 180 degree equal to pi. Easy to remember.
Just
Okay.
one. Oh, OK.
Yeah. Okay. You can convert anything. How about the last one?
270.
270 is 390, right? Three half.
3 half.
So that is be the 3 half pi. Can you see? Make sense now?
Yeah.
Then we're going to sine. Okay, they're going to put sine. This is special angle theta, sine theta. Then go to cosine theta. This is tan theta. Okay, that is a special value. So I can make a proper table for you. So that is the value we need to know. Okay, we need to know this value. So how about sine 0 degree?
Sine?
Yeah, we can use the unit circle to help you to work.
Sine 0 is 0.
Yeah, 0. Okay. Can we just make this table? Okay. And just do that. So basically, sine is a special angle value. So that is 0. Can you see? How about the cosine 0 degree?
0.
No.
Cosine
x to
x.
Yeah. 0 degree x equal to unit. Can you see? Remember, this is a unit. This is 1. Can you see? This is a 0, 1. This is a negative 1, 0. Can you see? So this is 1. So this distance is 1. Can you see? When theta equal to 0, remember? Can you follow me? This is theta. When theta equal to 0, what is x? What is x coordinate? Yes.
1.
Makes sense?
Yeah. Because the radius is 1.
Okay, the radius 1. So that should be 1. Can you see? Okay. How about tan?
tan
Special angle?
Is y over x.
What is y?
Y is y.
Yeah.
The gradient.
Not gradient, the coordinate.
Coordinate.
Can you see the coordinate? What is this coordinate? It is
2.
no, is 1, 0. Can you see? What does it mean 0? What is y? Any coordinate.
Y is 0.
Y is 0. So at the theta
0.
to this 0. Yes, 0. All right. How about this would be the same because it's same position. Can you see? Can we just finish this one?
1
and 0. Can you see? Because 2 pi is same as 0 degree. 你要喝点茶吗？
不知道
90 degree. Okay, let's move to 90 degree. What is a sine theta at 90 degree?
Sine is
yes.
y.
So that is called, read this coordinate, 0 and 1. So what is 0?
0.
Sorry, this 0. 0 is x is 0. Y is 1.
Yeah.
Make sense?
Just read from the coordinate. Okay.
Make sense?
Yeah, it makes sense. 0, 1.
It's 1, 0,
and 0.
And 0. Okay. This is special angle.
But
this is infinity. Sorry, this is more this complete. This is infinity.
Why?
Because x equal to 0. X equal to 0. Okay. So that is something special. Okay. Now, how about the pi? How about sine theta? What is the pi?
Can I look at the side?
What is y? Y equal to 0.
Negative 1.
No, it's 0. Can you see 0? Y equal to 0.
Is x. Okay.
Negative 1 is x. Okay. Can I put negative 1 here? Where?
180.
Okay, negative 0. Can you see?
0 and negative 1.
Negative 1. Are you sure?
Yeah.
Okay. That's called a special angle. How about tan?
0.
0. Okay. Because y is 0. Okay. See? Can you see that? How about 270 degree, which is closer to 90 degree?
270 degrees.
What is y? What is y?
X.
What is y?
Y is negative 1.
Yeah, y is -1. Can you see?
X is 0.
That is 0 and -1. Okay.
Yay.
That would be negative. Can you see?
Oh,
How about cosine?
0.
0? X equals 0. Okay. How about
Infinity.
negative infinity?
Oh. Could it negative infinity?
Yes. No, must be specified the sign.
Oh.
Because based on this, we can draw. We can draw every graph.
Yay.
Okay. Now let's go to something. How about the 30? How about the 45 degree? How about tangent 45 degree? Tangent 45 degree. How about tangent 45 degree? Can you work it out?
Oh, tangent.
45 degree. Do you want to see the 45 degree? At the 45 degree, these two sides are equal. X equal to y. 45 degree only. What's the number? Y over 1 over 1.
1 over 1. Well, just 1.
For tangent only, okay? For tangent only. Okay, we got a lot of information, but now we have to draw the triangle now. Can you see? For 45 degree, what we can draw this triangle to help you to understand. So we can draw this triangle.
A triangle?
Yeah, we can draw a triangle. So can we draw the 45 degree triangle? Do you know the 45 degree triangle? So yeah. That is a 45 degree right angle triangle. You see that?
Okay.
So in this case, in this way, you can keep that. So this is 45 degree for sure, right?
Okay.
Because these two sides are equal. Can we call this side 1?
1.
This is 90 degrees. So what would be this 45 degree? Okay. So what is this side?
Oh, you use Pythagoras.
Pythagoras, yes. Tell me.
A squared
1.
B squared. No, just 1.
No, square root 2.
Square root 2. Oh. Sorry.
Okay. So what is, by definition, what is the sine theta? So this is theta.
Sine theta. Sine theta. Oh, not sine. Opposite.
Hypotenuse.
Yeah.
Can you see right? Can you write down here?
1 over square root of 2.
So 1 over square root of 2.
Oh, 这样子找的.
Okay. And if you can multiply the square root 2, you get this, what you call this is the same thing. You know how to do that? You just multiply square root 2.
No.
Oh, you forgot this one. This is called rationalize. So if you have the 1 over square root 2, if you multiply square root 2 on both sides,
yeah,
and these two canceled, so this square root 2 multiply square root 2 will become 2.
Oh, I didn't know that. Okay.
Ah, your teacher didn't tell you. Oh, remember, that's can you do, okay? But the same result, okay, same result. How about the cosine? Cosine?
Cosine is adjacent, 1 over...
yeah, it's the same.
Yeah, it's
okay.
The same.
Now, this case, I just write the number. I just write this convenience. People, they use this often, okay? You know it's the same. It is 1 over square root 2, okay? Square root 2. Okay, that's for the 45 degree. We solve the 3 special angle. Okay, so they are identical, right?
Yeah.
Cosine and sine.
And then you do
identical.
the same with 60 and 30, right?
Well, 60 we have to draw another triangle.
Yeah.
But we can't use
the
that.
Same.
So for the 35 degree, we have used this triangle. We have to draw this another triangle. It's called the equilateral triangle. You know the equilateral triangle? That's internal angle is 60 degrees. You see? If I draw that one, and in addition, I draw another height here. Okay, this is not very good drawing, but just tell you that how to
draw the lines. To me.
Yeah, can you draw that again? Can we redraw that? I want to perfect drawing.
Oh, you can just 把这打杠杠 to make.
No, I can just make it because this is once for all. So that's good. That's much better. Hope. And then I chop that into half. Can you see? Into half. So I got 2 right angle triangles now.
Yes.
Okay. In this triangle,
60 degree.
This is 6 degree. Can you see? 6 degree. And how about this angle? half.
Oh, half 30
Yeah,
degrees.
30 degree. So I can use 30 degree. Okay. So we should be able to work out this value by a sine. But in this case, if I call this side is 2, and how about this side? How about this half side?
1.
It's 1. That's it. How about this height?
Height.
Use,
use Pythagoras.
yes, what is this height?
我不能心算。
No, 2 square plus 1 square. No, 2 square minus 1. Can you see? Minus 1 square. Can you see that?
Oh.
Equal to what?
4.1 3.
Yeah, square root of 3. Can you see this square root of 3? Can you see that?
Yeah.
We can know exactly the 3 sides. So we can apply this to the 60 degree first. Can we pay attention to this angle? By definition, what is the sine theta?
那就是 opposite, then a square root of 3.
Yeah.
Over,
square root of 3?
Over 2.
Yeah, square root of 2. Good. That is special angle. You don't need a calculator. Okay. 3
Just
equals
draw
3.
triangles.
Yeah. 3 equals 3 over 2, right?
Yeah.
How about cosine?
Cos is 1
Yeah.
over 2.
1 over 2 half. Can you see?
Uh,
Very simple.
uh.
Now let's return to 30 degree. Can we use this angle?
Yeah.
Relatively speaking, by definition, what is sine?
1 over 2.
No, 1 over 2. Yeah, you're right. 1 over 2. 1 over 2. 1 over 2. Can you see that's a half? Can you see that's why? That's I know this is half. Can you see?
Yeah.
That's how without this calculator.
Oh, and square root of 3 over.
Yeah, so go to 3
over 2.
Yeah. Can you see that? How about tangent to 30 degree? Tangent?
Can we apply the same? Oh, no,
yeah, we can use this small triangle.
1 over the square root of 3.
Yeah. You get 1 over square root of 3. So 1 over square root of 3, which can be also written as 3 divided by 3.
Ah.
Okay. Lastly, how about 60 degree of tangent?
60 degree.
I have to use this angle now.
That's opposite of the square root of 3.
Over 1, can you
over
see?
1.
It's just it. Good.
Oh,
so
okay.
You don't know the calculator.
Okay.
You got exact value. This is called the exact value of special angle. Okay.
Oh.
Exact. Can we say that this topic is called the exact value. Exact value at special angle. Can you see that?
Oh. Yay.
So that is why this table is very important. Okay. And it's so important because if any reference angle happen to be the special one of special angle,
yeah,
we can solve that immediately.
Oh.
For example, let's go to good example. We can go to example. For example, we try this one. How about can we find the sine 210 degree? Can you find this one quickly?
Oh. Sine 210.
So this identify which quadrant? 210. Which quadrant? So this 100. This one's 180.
Oh no, wait, no.
Somewhere here.
Yeah,
can you see?
Here.
And what is difference between the how far from there? Because we need to find this reference angle. Can you see?
I can. Yeah.
How far?
210.
Can we rewrite? Can we rewrite that as 100 plus? Can you see? 108 plus how many?
2.
What's the difference between these two? 30 degree. Can you see that?
Yeah.
So therefore, how about the sine in the third quadrant? This is called Q2.
Sine is negative.
Yay! Yes, this is Q2. Can you see?
Yeah.
It's Q1. I think this diagram will help you to understand.
It's really helpful. Yeah.
So that will be negative. Can you see?
Yeah, negative.
Negative sine 30 now. I use the.
I 30 is a reference angle.
Reference
angle. Okay.
So what is sine 30?
Sine 30 is 1/2. Oh no, it's half.
Solved.
Yeah.
Can you see?
Yeah. Yay.
Okay,
That's it.
that
Okay.
is an important function of spatial
Okay.
angle.
Thank you.
And another thing is called a graph. Graph is very important. Okay, that is a graph of sine. I mean, it's theta, right? Sine theta, cosine theta, and tan theta.
Oh yeah, this is a bit what I'm most like confused about because
Yeah, first we just draw this theta. This is a basic function, and then we do transformation. All right, we do transformation afterwards. So what?
Because last time 老师讲的，I was like, what?
Yeah. So what? They are all periodic function, but you have to be careful how to draw the period. What is the period for these three functions?
Oh, that is a sine bx.
No,
period
is.
这是你上次讲过派。
You see, whenever you find the period, can see. So for in the case of the sine function, okay, if you have the sine theta, and you will notice that if you added the angle by 2 pi, can you see? At 2 pi, one term, they're not change. So that is periodical function. And also in general, you can put the n here. So in general, you can put the n here. Okay, so in general, you can put this as a sine theta plus n 2n pi, sorry, 2n pi. 2n pi, can you see that? And n equal to 0, 1, 2, 3. That is called a periodical function. So in this case, this is a period. In this case, okay. So this is a
so 上次的 pendulum one, you figured out the oscillation.
That's right. So in general, this is called a function if if x equal to x plus nt, then t will be called a period. Okay. This is general form for periodical function. This is special form. But be careful, for tan theta, you will find that it's pi.
Well, cos is the same, right?
Yeah, the tan theta, be careful. Tan theta is tan theta will equal to tan theta plus half pi, plus pi, sorry, n pi. So in this case, period is pi. Confused? So in this case,
what does the tan graph look like?
Yeah, we can draw that equal to pi, okay? But in this case, t equal to 2 pi, okay? Okay, let's draw this graph first. So we just, every time you just divide the period into 4 interval, right? 1, 2,
pi, 2 pi.
3, 4. That is period, okay? If that is a theta, if they use theta here, so that would be 2 pi, can you see? That would be the half of the pi, can you see? There will be half pi, can you see? How about this one? 3 half pi. Can you follow me?
That's like the unit circle, right?
Unit circle, but this time we count them as a straight line.
So the circumference.
You can count, yeah. If you use a unit circle, you can just repeat and count. But if you use straight line, and when the angle increase, that outside scale, can you say?
But the domain is within.
So in this case, so we have also work out this is 1. Here is 1, negative 1. Because maximum x, this maximum is 1. So do you know this notation? So if you have a sine x, the maximum, okay, which is always smaller than 1, can you see? This also apply for cosine theta, which is smaller than 1. That is called
without
amplitude.
any transformations.
That's in general case.
Okay,
in the general case, can you see? This is from the unit circle. You see, the value x and y is always more than 1. Okay, yeah. See. So in this case, y is between -1, you see, and positive 1, and so does x. Can you see? -1, positive one. That's maximum. Okay. So if I draw this one, so first we draw sine theta. Okay, so sine theta. So we have to use our knowledge now. So what is 0? What is 0 sine theta? 0. Can you see?
Oh, sine starts from 0.
Since
Cos
from 0.
starts from 1.
Yeah, but
Okay.
can we do it one by one?
Okay.
How about 45 degree?
45 degree.
Yeah, go to that.
1.
No, 45 degree.
Sorry.
1.4 divided by 2, so square root of 2.
How do you know that?
Yeah,
square root of
1.4 approximately.
Oh.
So therefore, 2 divided by 2 is equal to 0.7. You see,
Okay.
roughly. So that will give us a hint. So that is the quarter one will be half. Can you see? 7. This is a half. Can you see?
Yeah.
7 will be over here. Okay.
Oh.
How about 90 degree? What is 90 degree for sine theta?
90 degree 1.
Yeah. Yeah, this is 1. Can you see? Okay, I can rough to so you can draw that. This is a first quarter. You see? It's the first quarter.
Would it be just like symmetrical then?
Yeah, next time go down to what is the pi value?
The pi 0.
Yes, it will go to 0.
Oh.
So yes, this symmetrical is symmetrical here. So that's how to draw this one.
Parabola.
That's parabola. You have to draw it. If you have to find this angle. Okay. For example, what is in between? What is this angle? Give you the test. What is this? What is this angle?
What's between pi over 2?
So this is quarter pi. Can you see?
Yeah.
This is quarter pi. How about this value?
That's
3/4 pi. Does that make sense? Can you see 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi?
Oh, yes.
Makes sense?
Yeah, makes sense.
Okay.
Yeah.
Pi equal to 4 multiply 4/4 pi equal to pi. Can you see that? So I've done that. Did your teacher show you how to do that? How about how about 45 degree? How about sine theta here? -1.
-1.
3 pi.
3 pi over
2. That's a negative. Can you see? That be go negative. Can you see? This go negative. Can you see?
And then 2 pi is
0. Okay. So if you want to continue, you can work out this 2, the 0.7. Can you see?
Okay.
All right. That's how to work out the sine theta. Did your teacher show you that? No?
I think he did, but I didn't pay attention.
Okay. So this is a sine. So this is a sine function.
Yeah.
How about cosine? This is sine. So this curve represents the sine. This is a sine theta. Okay. How about cosine? Cosine start from 1. Okay.
Yeah.
Do you agree?
Can it start from -1? No.
Oh, you have to be careful. How can -1?
Oh, no, it starts from 1, yeah.
+1.
+1.
Be careful.
Because that's what the special angle is.
Special angle is. So start from this one. This is 0, 1. Can we use this? Can you use this different color? Can you use a green? I use a green color. Fine. Okay. How about half pi?
Can I look at
90 degree? Oh, you have to get it from me. 90 degree. Special angle.
0.
Oh, you have to learn now. You have to read to practice. Most students know this table now.
Really?
For 2 months.
This
is the first time. This is the first time, right? Oh, isn't it? Can we get this 0? Can I put 0 here?
Okay.
How about quarter pi? This is quarter pi.
Quarter pi.
Yeah. This is a quarter pi. Can you see? This is a quarter pi.
0.7.
Yeah, same thing. Can you see?
Okay.
You remember now?
Yeah.
Yeah. So that would be the same number. So then we can draw that now for cosine.
And it's going down to -1.
Okay.
For pi.
And until you go to -1 pi here, can you see?
Yeah.
You can find a middle point here to join them to get this one. Okay.
And then it's going back to
half pi. Okay, and go up.
Yeah, 0.
Go to 0 here. And go to positive 1. Can you see?
中间路过 0.7.
I go to 7. Make sense?
Mm.
Of course, you can continue. Can you see? You can continue to draw. Can you see that?
Mm.
Because the periodic function, this is time, this is theta, is negative theta. Can you see?
Mm.
This will be the negative theta. Make sense? So this is a theta is negative. So this side is theta is negative. This side is negative. Theta is positive. So how do we decide the sign of theta? So if you count from here, so theta is positive. You can see. If you count theta clockwise, theta is negative. Okay. So when you say the people say that what is a negative 30 degree? Where is the negative 30 degree? Negative 60 degree.
Oh, negative 30 degree.
Where do you count?
Oh.
You count from here. Can you see? This
okay.
30 degree negative. Can you see?
Yeah.
Make sense?
Clockwise.
You need to review.
Clockwise, anti-clockwise.
Okay. Next, can we just draw the tangent? Tangent is a little bit different. Okay. I don't want to overlap that. Can you see that it's just like the red one is by shift the orange one backward by half pi.
Oh yes.
How do we write this question? So how can we use mathematical equation to define this shift? So this is cosine theta. Can you see? This is cosine theta. Do you agree? But also it will equal to sine theta plus half pi.
Oh,
Does that make sense?
because it shifts
backward.
Negative, yeah.
Back by half pi.
Mm.
Do you know this?
Yeah. It's the same as other transformations.
This here I use transformation.
Oh.
I use mathematical transformation.
Okay.
And of course, you can also say that sine theta. If I just consider we can consider it's come from cosine theta. Do we want to plus?
So minus
pi. Can you see that?
Means it moves forward.
Can you see that?
Yeah. Okay.
Okay. Finally, need to draw the tangent. Tangent theta is different. Okay. Tangent is different. And so tangent theta is from here. What we draw here is 0 at the center. Okay. This is half pi. Okay. And this is negative half pi. Negative half pi. And it is pi. Will be negative pi. Can you see? Okay, let's draw the first. How about theta equal to 0? Theta equal to 0. What is the tangent theta? I use purple. Tangent theta at theta equal to 0.
0.
0. Okay. 90 degree.
1.
No. Infinity.
Oh.
Infinity.
I'm still not familiar with the table. Yes.
Look at tangent. Tangent says that. How about 45 degree?
1.
1. Okay. So when you pick up these 3 values, that's enough. So this is can you put this 1?
I know how to remember it. So tan is either infinity, negative infinity, 1 or 0.
Yeah, that is 1. Can you see this is 1? Yeah. So that's half. This quarter will be here. Can you see?
Oh.
Can you see this half? This is when the quarter equal to 1. Okay. Then that is the whole things. If you draw this graph, this is how tangent behaves like this. Can you see? Go to infinity. Can you see?
Oh. That's a tangent graph.
It's tangent.
Okay.
And on the other side, I just cut the story short. So this is 1, 1. So just go here.
Oh.
Can you see that? Let's do it again.
That looks like a cubic.
It's not a cubic.
But it's not.
Like a cubic. Yeah, like a cubic. It's like a cubic, but different. Okay. And so this pattern just to show off. So this is a difficult one to draw. Can you see? So this just it's just to the asymptote. Can you see? This called
Asymptote.
asymptote. Asymptote. So this can be to this asymptote here.
Asymptote.
So we can make it a periodical. We can make it a
吓
periodical function now.
Yeah.
So in this one, so this got the same. Can you see that is just repeat itself? Can you see?
Oh, like this.
And then go to infinity.
From negative infinity to infinity?
Yeah,
Oh.
can you see? From negative, can you see it is again from negative? This is difficult to draw, can you see? And then go to positive infinity. So this is tangent in
I
the
don't like this.
yeah. And it's very useful.
Oh.
Also, these are basic. This is tangent, okay? Tangent theta. Okay, if you're tired, we'll stop here.
Yeah, thank you.
Next time we'll talk about transformation of the graph.
We already touched on transformation.
We touched transformation, but next time we'll draw how to draw this y equal to a sine. I just go to next page. Next time we'll continue to draw a sine b bracket x plus c plus d. Okay. That is you have to use a little bit of imagination.
Yeah,
All
thank
right,
you.
we'll stop here, and this is the first lesson.